Okay, let's do a problem utilizing Avogadro's law. Okay, so first of all, what is Avogadro's law? One student asked for a little bit of background information on that. So what I'm going to do is I'm going to come over here and I'm going to say, all right, let's start out with some definitions. Let's get a couple layers here. All right, start out with this one and say that Avogadro's law is, where am I here? Am I good? Let me go black. Somehow my pad, oh, it's not plugged in. Sorry, my notepad is not plugged in. Got it. All right. So, is that working? It's probably take a second. There you go. Okay. So, where am I here? Tell me. There we go. Okay. So, Avogadro's law. All right. Avogadro's law. I'm just going to Google this. Let's say I Google it now and I find out this, that the moles of some gas are related to the volume of that gas. Here's the big deal. At constant pressure and temperature, then if you have a different gas, that ratio is going to be the same, right? So the moles per volume is going to equal to the moles per volume, all right? So you could have the same gas at different volumes. You could have the same volume for different gases, or you could have a different gas and a different volume related to a different gas and a different volume. Okay, so we know this, that the moles at a constant, here's the big deal really, at a constant pressure and temperature, N1 over V1 is equal to N2 over V2. All right, so what does that even mean? And that's really going to be difficult to appreciate until we do some problems. All right, so I first of all look up Avogadro's law, and I find that basically it is N1 over V1 is equal to N2 over V2. All right, so then the next thing you do is, let's suppose we've got that. Let's come back over here. So we're using Avogadro's law. Now, methane gas and oxygen gas react to form water vapor and carbon dioxide gas. All right, so when I first looked at this, I said to myself, I'm going to have to go back and review what methane plus oxygen produce carbon dioxide and water, right? I'm going to go ahead and write those formulas out. Carbon dioxide and water, okay? But you might have to look up what methane is, and you might think, uh-oh, I'm in trouble, okay? Turns out I don't think we need to even know what that is. All right, let's go back and look at the question again. So suppose that we, oh yeah, we do. We have to know what methane is, yeah, because it says if we've got this many liters of methane, what's the volume of water that's going to be produced? All right, so yeah, we do have to know what that is. All right, so I'm going to come over here and change this to red, and I'm going to pretend like I have this memorized, right? This is a previous topic. You did get this correct in a previous topic because it's something we're supposed to know. But if you don't know it, you have to look it up. And oxygen gas looks like that, right? And carbon dioxide, of course, I've already got that written out, gives water, okay? Now what I have to do is I've got to balance this, all right? So, because if I don't know how many moles, where am I here? Moles in volume, I'm given those, and I'm given those in the question, I think, right? And if I'm going to relate these, I'm going to be relating through a molar ratio, which you've done this just recently. You did stoichiometric coefficients and molar ratios. So it's 7.03 liters of methane. 7.03 liters of methane. Well, let's suppose that I start out with 1 mole of this, right? All I've got to do is find out how many moles, what my volume is in the end. That's my question. Okay, that was the volume that I was asked, okay? No, volume of water. Sorry, not carbon dioxide, water. Right? So what I've got to do is I've got to find out, I'm going to go from here to here to here to there, right? So if I've got 1 mole in 7.03 liters, then how many moles of water is that going to give me? In order to find that, I've got to balance my reaction, right? So let's suppose I start with 1 mole of this, and how many moles of carbon dioxide is that going to give me? 1 mole of that, right? How many moles of water is that going to give me? If I've got 1 mole of methane, it's going to give me 2 moles of water, right? Okay. So suppose I start with 1 mole of this. That's going to give me 2 moles of water. Okay, and now I'm ready to use my Avogadro's law. So let's go to this new layer. I should have put this in my new layer. I'm just going to put it all right here. Can I put it in green? N1 V1 is equal to N2 V2, right? And it's V2 I'm looking for. So let's turn this over and say V1 over N1 is equal to V2 over N2. And so this is going to be N2 V1 over N1 is equal to V2. Okay? And so N2 is 2, N1 is 1, and V1 7.03, so it looks like it's going to be 14.06. Okay? Now these numbers were exact, so I've got 3 sig figs here, an infinite number here because it's exact, an infinite number here because it's exact, right? And so it looks like I'm doing multiplication problems. This is going to have to be reported in 3 sig figs, okay? So this is going to be written as 14.1. Can you see that? 14.1 liters, okay? There's my answer. Now, I'm going to come back here and ask, what I'm guessing the most common misunderstanding is here. Someone might say, well, how did you know there was 1 mole here? And I would say, how did you know that? How did you know there was 1 mole? Well, I think the best way to explain this is to ask you as the student to put 2 there in its place. And if there's 2, if it's 2 instead, what's this going to be over here? Right? So start out by saying, all right, suppose it's not 1, suppose it's 2. If it's 2, what's this going to be? And I think you'll find out we get the same answer. Right? So the magic was okay, choose an arbitrary n, and I'm going to choose 1 when I'm choosing an arbitrary n. So let's go back and go to Alex. Got this open, 14.1. Give me some green here. The green, show me it's correct. And I may end up doing actually, oops, didn't put the units in there, liters. And I may end up doing another problem. Let's do another problem, okay? So we got our green here. This would be a good stopping point though. If you feel like you understand this, then go ahead and cut it off. Or it might be good to go back and recalculate that last one without the video and then watch the video again because you need the practice. All right, practice is where it's at. All right, so let's do a different problem. I'm going to come back here and I'm going to actually, let's delete this. Let's delete this. Control A, delete. And let's start over again, and let's say we're going to go with Avogadro's law. We know Avogadro's law is N1 over V1 is equal to N2 over V2. We know that's Avogadro's law. Okay? And let's go back here and say the question is methane gas and chlorine gas react to form hydrogen chloride gas and carbon tetrachloride. So yeah, we do have to know nomenclature here. It's we're being required to review the nomenclature. So it's methane, I looked that up again and I find it's that. Chlorine gas, it looks like that, gives HCl, I think it was, and carbon tetrachloride. Okay. So Alex is requiring you to review naming nomenclature. Let's go back here. Methane gas and chlorine gas react to form hydrogen chloride gas, that's HCl, and carbon tetrachloride. We got that right. Okay. What volume of HCl would be produced by the reaction of 6.04 liters? I'm sorry, it would be by this reaction if 6.04 liters of chlorine gas were consumed. Let's go back here and we're going to go, let's set up a table for ourselves and say the volume 6.04 liters, right? Now we have to balance this reaction out. I see that if there's 1 here, there's going to be 1 here, and that's going to give us 4 here, right? And 2 here. Now I'm going to make sure I read this question correctly, because it's really maddening if you get down to the end and find out you didn't have it. It's 6.04 liters of chlorine gas. That's right. That's right, and they're asking about the HCl. Okay. So I'm looking for this right here, right? So how many moles do you want to arbitrarily start out with here? Let's say we start out with 2. If there are 2 moles there, how many moles of HCl are we going to produce? 4, right? You see that? Okay. Now using Avogadro's law, I'm looking for V2, right? So I'm going to say N. I'm going to go ahead and flip it upside down. V1 over N1 is equal to V2 over N2. And therefore, N2 V1 over N1 is equal to V2, which is what I was being asked, right? V2 is, bam, agreed? So let's go ahead and fill these numbers in. I'm going to go with a different color now. N2 is what is N2? N2 is here. I'm calling that 2, and I'm calling this one 1, right? So N2 is 4. V1 is 6.04, and N1 is 2, right? So it looks like it's 2 times that. It's going to give me 12.08. Now this number was exact, so I've got an infinite number of sig figs here. This was exact, so I've got an infinite number of sig figs here, but this was not. That was a measurement. That's got 3 sig figs. So 3 is going to be limited to 3, right? Can you see that? So this is going to be reported as 12.1 liters. All right. Let's go back here and say, make sure I got it right. What volume of HCl? Is that what I was asking? Indeed, it's my volume of HCl. Indeed, it was 12.1. Okay. Let's come back here and say 12.1 liters. All right. Give me some green. Hope that's helpful. Oh, what happened? Your answer is wrong. In addition to checking your math, that you did not round any data. Did I do that in my head? I did. Where did I go wrong? Oh, I didn't balance this right. Look at that. Oh, that hurts. I'm really sorry, folks. I'm going to leave this on here, though, because I didn't balance this right? You see, if I have 4 moles of that here, this is a mistake. So I got 4 moles of HCl. It's going to take more than 2 moles of that, because there's 4 chlorines over here too, right? So here's 4 chlorines, and here's 4 more chlorines. It's going to give 8 chlorines. This needs to be 4. Ugh, frustrating. Okay, so this is 4, and so that's going to be 4, and so this is going to be 6.04. Crud, hate that. Easy to do. 6.04 liters. Recheck. Okay, didn't have my problem balanced correctly. I'm going to do another one. This is going to make for a really long video. Not a nice long video, but that hurts my feelings I didn't get that right. So I'm going to do another one. And you may want to cut it off at this point. Control A, delete. Control A, Control D. All right, but I'm going to do another one. So let me come back here and say N1 V1, because we're still doing Avogadro's law, right? N2 over V2, and I'm gonna get a new reaction here, and it was hydrogen gas and nitrogen gas react to form ammonia. Okay, hydrogen gas plus nitrogen gas react to form ammonia. Okay. My wife is here. She's waiting for me in the parking lot, so I'm going to cut it off after this this one. H2. This is going to give me 2, and this is going to give me 3. Okay. Let me just tell her. Let me text her real quick and say, "Be right out." I'll be right out, baby. I'll be right out. Okay. Now let's go back. This one doesn't require no naming, I don't think. Well, I mean, you have to know what hydrogen gas is, but my feeling is that's going to be a little easier than using methane. So 7.6 mils of nitrogen were consumed. If 7.6 mils of nitrogen are consumed, milliliters, and let's suppose this is 1 mole, so we'll go 1 mole. This is going to give me 2 moles of that. What volume of ammonia are we going to produce? Okay, make sure I read it right. 7.6 mils of nitrogen. Pretty sure I got the equation balanced right. Let's go now. We're looking for a final volume, so I'm going to say V2 over N1 is equal to V1 over N1. Oops. V2 over N2. Okay. So V2 is equal to N2 V1 over N1, which is equal to N2 is here, 2, and 1 is here, that's 1. V1 is here, 7.6. So it's going to be 15.2, right? And I'm supposed to write this as 2 sig figs. This is an infinite number of sig figs, and so is this one. So we're exact, right? So this will have to be written in 2 sig figs. This is going to be written as 15 mils, okay? So let's come back here. 15 milliliters, and we will give me some green, and we'll be done with it. Okay. All right. Hope that's helpful. I balanced a reaction incorrectly in the second example, so we got it wrong. That can be pretty frustrating, right? Okay. Hope that's helpful. Good luck.